Linear program example number 3. So this one I think is really interesting. It has a lot of real-world application. So what we have here is a company recently received an order for these slip rings, then will receive $750,000. Now this order requires that they produce 3,000 of Model 1, 2,000 of Model 2, and 900 of Model 3. All right, but to create Model 1, it requires 2 hours of wiring, 1 hour of harnessing. Model 2 is 1.5 and 2. Model 3 is 3 and 1. Okay, but here's the information that makes this really interesting. Unfortunately, MP does not have enough wiring and harnessing capacity to fulfill the order by its due date. They only have 10,000 hours for wiring and 5,000 hours for harnessing. So because we can't actually fill this order, you have to be a problem solver. And rather than go back to the company and say, it turns out we can't fill your order and lose that whole bid, we want to say, well, let's go ahead and subcontract some of this out to a competitor or someone else that makes this and see how much it costs us to do that. So to make it in our factory, Model 1 costs $50. To buy it from a competitor, it's $61. Model 2 is $83 and $97. Model 3 is $130 and $145. And so what we want to do, our MP company wants to determine the number of slip rings to make and the number of slip rings to buy to satisfy the customer order at the least possible cost so we can make the most money. Okay? So let's think now, what are our variables? What is it that we get to choose? Well, here we can choose to make Model 1, make Model 2, make Model 3, or we can choose to buy Model 1, buy Model 2, and buy Model 3. So we have 6 variables or 6 things that we can choose. Okay, so to set up our linear program, step 1 is define our variables. So I'm going to let x1 be the number of Model 1 that we make. x2 is equal to the number of Model 2 that we make. x3 is equal to the number of Model 3 that we make. Now normally that's all we would do, but here the information we're given is we can't actually make all of Model 1, 2, and 3 and satisfy the order of the customer. So we need to add some more. So let x4 equal the number of Model 1 that we buy, x5 the number of Model 2 that we buy, and x6 equals the number of Model 3 that we buy. Okay, so once we set up these variables, now we need to think about our objective function. Okay, and again, I want to encourage you, by doing this step by step, doing step 1 first, step 2, then step 3, it makes the problem a lot more manageable. So our objective function we looked at is to fill the customer order at the least possible cost. So this least possible cost tells us that is our objective. So how much does it cost us to make Model 1, make Model 2, make Model 3, buy Model 1, buy Model 2, buy Model 3? That is our cost function. So the second step is to minimize our cost function, which is equal to, well, how much does it cost us to make Model 1? 50 times the number of Model 1s that we make. To make Model 2 is 83 x2. Make Model 3s 130 x3. Make Model 4s, well, there's no Model 4, so x4 is how many Model 1 do we buy? Well, it's a little more expensive to buy Model 1, so that's x4 plus 97 x5 plus 145 x6. All right, so that is our minimized cost. Well, now the question is, what is our constraints? Well, the first constraint should be, do we actually fill the order? That's what we're supposed to do. So if we make Model 1, or if we buy Model 1, that needs to be at least 3,000, because that's what the order is. All right. Now it can be greater than, but because our constraint is only this, when we think of our objective function, this is going to be a binding constraint, meaning it's going to be equal. But we want to set it up as greater than or equal to. The next constraint is if we make Model 2 or if we buy Model 2, it has to be greater than or equal to 2,000. And with Model 3, the same thing. Okay, so that is the order requirement that we need to fill. Okay, well now what other requirements do we have? Well, what if we make models 1, 2, and 3? What does it require for that? Okay, so I'll put little I's here. Okay, so now to make model 1, this is going back to what we did before, is it's going to be 2 times x1 plus 1.5 x2 plus 3 times x3 has to be less than or equal to the amount we have. Okay, so we're going to set this up as 2x1 plus 1.5 x2 plus 3x3 has to be less than or equal to 10,000, the number of hours we have available. Our fifth constraint is that 1x1 plus 2x2 plus 1x3 is less than or equal to 5,000. All right, the harnessing requirement. And that's all we got. So here is we're going to minimize our costs by filling the orders and by producing the best we can within our factory. And now we just need to put this into Excel and solve.